Lesson 9-2, Understand Theoretical Probability. I can determine the theoretical probability of an event. Before you start this lesson, take a look at the solve and discuss it. What do you think? What should Betty and Carl expect their results to be? Example 1. Use theoretical probability to make predictions. Talia and Yoshi design a game for the school fair. Contestants spin the pointer and win a prize if it lands on either of the two red sections. How can Talia and Yoshi determine how many people are likely to be winners if 500 people play their game? Step 1. Determine the total number of possible outcomes from one spin of the pointer. Well, on this spinner, there are 16 sections that are all the same size, and there are 2 sections of each color. The pointer could theoretically land on any of the 16 sections, so there are 16 possible equally likely outcomes. Step 2. Because you know all the possible outcomes, you can find what we call theoretical probability of an event, such as the pointer landing on red. When we talk about probability, you'll often see the abbreviation capital P to represent theoretical probability. An event is the single outcome or group of outcomes. In other words, the probability of the event that we want to have happen tells us the number of favorable outcomes, or what we want to have show up on that spinner, divided by the total number of possible outcomes. In this case, the event that we want is landing on red. So the probability of landing on red means what are the total number of red sections divided by the total number of sections altogether. The theoretical probability here is 2 out of 16 because there are 2 red sections out of 16 sections total. But that simplifies to 1 out of 8. So the theoretical probability that a contestant will win this game is 1 out of 8, or 12 5/10%. Step 3. Use proportional reasoning to predict the number of likely winners. W will represent the number of likely winners. When we set up a proportion, we use our theoretical probability as one of our ratios. The second ratio is the number of winners that we expect to have happen out of 500, which is the total number of winners that we hope will play this game. In this case, to solve this proportion, you can multiply both sides by 500. Those two cancel out on the right side of that equation, and the left side becomes 1/8 times 500, which is 62 5/10. In other words, out of 500 contestants, about 62 or 63 are likely to be winners. Now look at the try it. If Talia and Yoshi redesign their spinner to have 14 sections instead of 16 sections, would they likely have more or fewer winners? If you said more winners, you're right. With only 14 sections on the spinner, and 2 of them still being the red winning sections, the probability now changes to about 14 3/10%. Now take a look at example 2. Archie plays a word board game. He places 98 lettered tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be a blank tile, labeled with a letter, labeled with a vowel, labeled with a consonant? So let's take a look at all of these probabilities. Recall that the problem said he placed 98 lettered tiles and 2 blank tiles in the bag. That means that there are 100 tiles altogether. So the probability that the first tile drawn will be blank is 2 out of 100, or 1 out of 50. The probability that the first tile he draws has a letter on it is 98 out of 100, or 49 out of 50. The probability that he chooses a vowel is 42 out of 100, or 21 out of 50. And the probability that he pulls a consonant on the first try is 56 out of 100, or 28 out of 50. Let's take a look at the relationships of these probabilities to each other. If I add together the blank tiles and the letter tiles, I get all 100 tiles. But if I add the vowel tiles and the consonant tiles, I don't. I only get 98 tiles. Why is that? Don't forget that vowels and consonants are part of the subgroup of lettered tiles, which means you still have to account for the 2 blank tiles here in that picture. Altogether, the probabilities should add up to 1 whole, or 100 tiles out of 100 tiles. Now take a look at example 3. We're going to use theoretical probability to make more predictions. Joaquin also designs a game for the school fair. Contestants roll 2 number cubes at the same time. If the sum of the numbers on the 2 cubes is 7, a player wins. About how many winners should Joaquin expect if 500 contestants play his game? Step 1 is to first of all find all the possible outcomes and all the ones that are winners. So when you take a look at the table, you see that the first number cube has 6 outcomes, 1 through 6. And the second number cube also has 6 outcomes, numbered 1 through 6. And in looking at that table, where the 2 numbers converge, you'll see their sum. Here, we see all the places where he can get the number 7. From a 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4, a 2 and a 5, or a 1 and a 6. So there are 6 ways to win this game out of a total of 36 possible combinations of rolls. Step 2 is to find the theoretical probability of rolling a sum of 7. Well, that sum again is 6 out of 36, or 1 out of 6, because there were 6 sums on the table that gave a winning combination of 7 out of 36 possible combinations. Step 3 says use your proportional reasoning to predict the number of winners. So 1 out of 6 is the theoretical probability, but if we want to know about how many winners to expect out of 500, then we have to set up that proportion. Multiply both sides of your proportion by 500, and 1/6 times 500 is about 83 3/10. So out of the 500 contestants, Joaquin should expect about 83 winners. Now take a look at the try-it that goes with example 3. Joaquin wants to reduce the number of winners so he does not have to prepare as many prizes. Choose another sum he could use as a winning sum and predict the number of winners if 500 people play his game. In this case, when you look at the table, there is no other sum that occurs more often than the sum of 7. So any of the other sums would produce fewer winners. Let's choose the sum of 4 as an example. If the sum of 4 is the winning sum, then you can see in the table here marked in red the number of times that that sum of 4 occurs. And it occurs 3 times out of the 36 possible combinations. That 3 out of 36 is the same as 1 out of 12. If the sum equals 4 is the winning combination, then predicting how many winners you have out of 500 is as simple as setting up that proportion. 1 out of 12 equals what out of 500? Well, by solving that proportion, you get x to be about 41 7/10. In other words, you should expect about 42 winners. On this page with the key concept, make sure you pay special attention to how the outcomes are determined. The probability of an event is equal to the number of favorable outcomes divided by the total number of possible outcomes. You can also use theoretical probability and proportional reasoning to make predictions, such as in a game situation. Now try questions 4 through 6 and come back and check your answers. Check your answers to questions 4, 5, and 6. The last 2 questions I want you to try are numbers 11 and 12. You'll find these questions on page 518. Pause the video while you work them out, and then come back and check yourself. Check your answers to numbers 11 and 12, and see me if you have questions. Now it's time for you to try some. Log into your Pearson account and get to your MathXLs. 9-2 MathXL is in your account.